All right, we're up and running. So this is what you see on, you should be seeing the shared screen. No picture of me today. I was sharing ahead of class with some people, and I decided, exited out of that. I couldn't get back in, and we had to restart. So I'm going to leave it there. But I am gonna go back to the beginning. Just put up the first slide. We are open to questions on what is it, 1.3, which was basically word problems. Looking at the lesson ahead, it's a pretty stiff lesson. Plus the fact that we probably will need to go through the questions on the word problems. We probably will just get a start today on lesson 1.4, and I'll have to finish it up tomorrow. Let's open it up. Anybody on hand? Questions from lesson 1.3, the mixture problems, and other kinds of problems.
Can we try 65 once? Thanks.
Okay, number 65. We'll start with that. Yeah, I'm trying to share the whole screen. Okay, I got 69 for requests. Thank you from the text message. Thanks for the name. I appreciate it. Good. Okay, so right now we've got a 65 request. Anyway, I'm sharing the whole screen, so that causes I have to do a little scrolling like this. So anyway, let's just start here. All right, so let me read it here. 65. Shadow length. A person who is 6 feet tall walks away from a 50-foot silo toward the tip of the silo's shadow. You see my incredibly crude drawing here? Sorry for the stick man. This is the silo over here on the right, and believe it or not, this is the sunshine up here. And the dotted line is showing you where the edge of the shadow comes down. So this is all shadow down here on the bottom. Okay? And the guy is, yeah, the 6 foot tall guy is there. Okay, continuing to read. At a distance of 32 feet from the silo, the person's shadow begins to emerge beyond the silo shadow. How much further must a person walk to be completely out of the shadow? So that would be the X in my drawing. See that? So if he walked X feet further, and right now the guy is supposed to be, he's right at this line, 32 feet away from the silo. But if he moved to the left, to get out of the shadow, he'd have to move X feet. And that's the unknown. Okay? All right. So, what do we got going here? I decided, maybe you can't see it, but there really are two triangles here. Let me sketch in another line right over the guy. But anyway, there's a big right triangle that I'm going to put in blue, this one. Hopefully you can see that. And there's a little right triangle, which is also a right triangle, which I have made in red. Because they're both right triangles and they both have this angle of the sun down here, the same angle, they must be similar. And if they're similar, the corresponding ratios of the sides must be proportional. So that's how I set this whole thing up. So the height of the little triangle, 6, is to the height of the big triangle, 50, as the bottom side of the little triangle, X, side of the big triangle, please note, X plus 32, right? Because 32 only goes up to here. So the whole thing is X plus 32. So that's how I arrived here. Let me just pause there. Did you, anybody have a question about that? So I set it up by using similar triangles. Ratios must be equal. Of course, once you have a proportion equal, you can do cross multiplication of the proportion. So that's what I did as we moved forward here. I took the top left 6 times the bottom right, x plus 32, and that equals the bottom left times the top right. And then it's just a matter of, from there on in, it's simple algebra. I didn't actually, yeah, so I wound up with 48/11 feet. That's what? That's 4/11 feet, so about 4.5 feet. I mean, let's just leave it at 4. Here, let me write it out. X equals 4 and 4/11. So either one of these two answers here on the left is fine. Any follow-up on that, Brandon?
No, that makes a lot more sense. I just set it up wrong.
Yeah, that's the big thing in these, isn't it? How do I set it up?
Yeah.
Yeah. Okay, anyone else? The next one in the queue is number 69, but did anybody else have any feedback on? Okay, 69 was requested, so we'll go to that one next. So, a mixture problem. Sorry, it's kind of sloppy, but here we go. An automobile dealer has $600,000 worth of inventory in compact cars and mid-sized cars. Compact car is 24%. The profit on a mid-sized car is 28%. The profit of the entire stock is 25%. So the question is, you have invested in each type of car. Okay. So, 2 types of inventory, compact and mid-size. So you see here on the left, I've got those 2 rows, if you will. How do you figure out amount of profit? Well, you take the amount of dollars times the percent of profit, and that'll give you the amount of profit. So it's just like that R times T equals D, and it's different letters. So what do you have invested? What's the percent of profit? So what is the amount of profit? So column, this column times this column should equal this column. So it's a lot like the R times T equals D. So I was not very original. I said, let's say he has X dollars invested in compact cars. And we know the total is 600,000. If you look, I called it overall. So doesn't this one have to be 600,000 minus X? And then they gave us the 2% of profit, 24%, 28%. So we should be able to get these 2 expressions on the right. What's the amount of profit? All right, so the top one, 0.24 times X. The bottom one, I multiplied that out. I multiplied it out. 0.28 times 600,000 minus X in parentheses. And I already did it here. This is the result over here on the right. Okay, so when I add those up, I should get the total profit. But what's the total profit? This bottom line, I have this total amount invested, 600,000, and I know this is the overall rate. So can't I multiply those 2 to get the answer? Yeah, if you do it, you get 150,000. So now I got it. The profit for the compacts, 0.24x, plus the profit for the mid-size, 168,000 minus 0.28x, equals the total profit, 150,000. And that's the key. That's the setup. This comes from. That's just the plus the mid-size profit equals the total profit. And then it's just algebra. I solved for X, gathered like terms, and I came up with the compact investment at $450,000. Well, the total investment was $600,000, so just subtract. That means he must have had $150,000 in midsize. So, Sophie, follow up on that? That's number 69 on the assignment from 1.3. All right. I'm looking for other questions from 1.3 that through, and I will check text messages here and just see if I missed any that came in that way.
I'd also like to ask about 85 if you don't have any other questions first.
I'm not seeing any others that came in. What did you say, 65?
No, 85.
All right, 85. You got it. 85 is next. Okay, 85. So, looking up the problem here, they gave us an equation, which I have on the top there. Oh, we got another request. Oh, yeah, okay, not a new request, just an acknowledgement. Okay, good. Thank you for the message. So now, the top, that's just from the book, right? Okay, solve for R1. Wait a minute. No, solve for A. Correct, Brandon?
Yes, that's correct.
Get A isolated in that thing. So I got a whole bunch of stuff I got to get out of there. So I decided, how about if we just get rid of that V0T term by subtracting that from both sides. Okay, I should have done more steps here, but that gave me, oh, I do have another request, number 33. Okay, I did do that earlier, but we'll go back and look at it, yeah. Thank you for the request. I got to remember to go back there now, but anyway. So Brandon, that brought me to the point where I just have what? Yeah, I guess, let me see if I can write it in there. So now we're at the stage where we have H minus V0T equals 1/2 AT squared.
Yeah, I see that.
Okay, so I'm getting there. I need to get A alone. If you look at the next step, I decided to multiply both sides by this thing in parentheses because I took care of getting rid of the 1/2 by multiplying both sides by 2, and I took care of getting rid of a multiplied t squared by dividing both. So I'm getting rid of two things at once here. On the right, of course, it achieves the goal. You see how I wind up with just A, and of course that was my goal. On the left, I have to multiply that whole quantity, H minus V0T, times that. So I got to do a distributive property. This. So maybe you're wondering, how did I, so just what's 2 times H? 2H, T squared on the bottom. Okay, I guess it's pretty simple multiplication, isn't it? Do you see why I wound up with a single T on the bottom of the second term here? Right here? Because I had a T on the top and a T squared on the bottom.
Oh, okay, yeah.
Yeah, I can't really improve on this. That's what I'd put down for my answer. Okay, anybody follow up on 85? Otherwise, 33 has been requested. Those of you who were in here early, but I'm going to go back because not everybody was in here then. Anybody else follow up on number 85? Okay, 33 it is. Okay, 17 and 21. Wow. Okay, let's see. I don't know. I'll try to get those in. Thank you for the request. So number 33, everybody. So let me go back and find the problem. 33. Find two consecutive integers whose product is 5. I'm sorry, whose product is 5 less than the square of the smaller number. So two consecutive integers. As I was saying before, 91. Okay, got another request. Thank you for the request. So, and number 33, consecutive integers. So I started with A. You could start with X, I don't care what. But the next one has to, if it's consecutive, has to be 1 greater. So I'm saying let's call the two numbers A and A plus 1 until you do that. Okay, now, the wording of the problem, the product is, what's multiplied? Oh, the two numbers. So you see how I wrote the first number, A, times the second number, A plus 1, that's the product, is equals, here's the one that everybody gets goofed up on, 5 less than the square of the first number. How do you write less than in algebra? You have to put the subtraction on the end. You can't say 5 minus because it has to come, you know, you got to first write down the square and then you have to subtract the 5. So that part is where most people have trouble with this. Once you see that, well, now it's just an equation. I don't think the rest is too bad. On the left side, you multiply it out. And then, how did I get from that to the A equals negative 5? I subtracted A squared from both sides. And bingo, there it just comes right out and tells me A is negative 5. Well, if A is negative 5, what's the other number? Just 1 greater than that? Plus 1, negative 4. So now we've got them both. All right. So I've got 3 more to do. I think I'm gonna have to cap it at that. That'll give us 1, 2, 3, 4, 5, 6, 7, 8, 9 examples we will have gone through. I wish I could do more, and I will if you come and see me or write to me. But anyway, 17 has been adjusted. Let's see if we have that. So we will make a slide for that. Okay. Number 17 is our next problem. Okay. Write an algebra. So number 17. Write an algebraic expression for this. The amount of acid is of 20% acid. So that's that's like rate times time equals distance again. All right. The rate in this, except it's not, there's no time here, but I mean, it's like, or principal, remember how we times rate equals interest? It's this old one thing times another equals the other. How do you find how much there is? And if there's, so 20%, that's the rate. And X is the number of liters. So what's the amount of acid? Just 0.20x or 0.2x. And that's pretty much it. They're just trying to get you in practice to do the problems later in the assignment. Number 21 is similar, so I'm going to throw that on. Somebody asked about 21. I'm going to throw, and they said it's wording again, and I'm sure that's half the difficulty in an assignment like this. The cost of producing X units for which the fixed costs are $1,200 and the cost per unit. So, okay. So if you look back at examples, fixed costs, that means I bought a machine for $1,200. No matter how many I sell, I have to pay that $1,200 because I bought something. Fixed cost is like equipment costs, something that you just got to pay the bill. So what we got here is it's like fixed cost plus, what do they call it? The I don't know. I shouldn't use those letters. Let me just write it out. So it's fixed cost plus, okay, now how many units do I have? What's the cost per unit? And then that'll give you the total cost, okay? So in this case, the fixed cost is $1,200. And the cost per unit is 25. And we don't know how many units, so we're going to just say that's X. So fixed cost plus the price per unit times the number of units. So this would be what they're looking for on number 21. And then number 91 is the last one we're going to do or talk about. I'm going to make a slide for this, so hang on just a second. Number 91. Volume of a billiard ball. A billiard ball has a volume of 5.96 cubic inches. Find the radius. All right, now, you might have had to do a little research. What's the volume of a sphere, which I'm assuming the billiard ball was round, right? Well, you may have to do a little looking, but it's 4/3 pi r cubed, okay? Probably a formula you should know, but anyway, I obviously didn't teach it to you, so go looking. Oh, basically now you know, basically the volume is 5.96, and the rest of the formula is 4/3 pi r cubed. Can you solve for r? So now it's algebra. What I need to do, let me change colors here to black. I first of all need to get the thirds and the pi out of there. Okay, so how can I do that? Well, I can multiply both sides by what? By 3/4, right? Because what's 4/3 times 3/4? And that'll be gone. And I need to what? Divide by pi. So that's what I need to do first. Of course, if I do it on that side, I got to also multiply by 3/4 pi. So that's how I begin. So the right side now has 4/3 and pi gone, and you have r cubed equals this. So you just have to multiply out. I'm not going to do it right now. You could get on your calculator or whatever and multiply that times 5.96. So once you have r cubed, how can you find r? You take the cube root. So, I mean, this isn't as complex as it looks, but I'm not going to do the calculator stuff right now. So now you this multiplication, done, you do a cube root, and you would have the radius of your billiard ball. and then double check. Does it make sense? I mean, if the thing comes out to a radius of 24 feet, longest billiard ball, I mean, make sure it makes sense. It should be, what? I don't know, inch and a half, or inch. I don't know how. I'm not a billiards player, but you know, it can't be a lot more than that. Okay. Hopefully that answers the question from the person who asked about 90. All right. Good questions. Big chunk, but that was well spent. Thank you for your questions. Let's get started on the 1-4 lesson. I knew even before the questions that actually there's a little too much here for one day. Okay, so we're going to get started. Okay, so this is the title of the lesson, Quadratic Equations. Up there, you can just ignore it right now, but it's kind of a picture of some problems that involve quadratic equations, and we may return to that. But rather, you can look at the objectives down below. Eventually, of solving quadratic equation. First of all, what's a quadratic equation? A quadratic equation has something other than degree 1. So in other words, quadratic means second degree. Parabolas, y equals x squared something. Number 5, a request? I don't know. Let's see. Another request? I will, if not, the person who requested number 5, could you tell me who you are so that I might have to send you the results by email or text message or something, okay? All I know now is you are 9, all I have is your phone number. I guess that's enough for the text message. Let me quick write it down. 928. Because I don't have all of your phone numbers, who this is. Okay. Okay. If I don't have time to go to number 5, I will do that one outside. Oh, is it 45 or 5 that you wanted? I might have read it wrong. Is it 45? I'm sorry. 45. Got it. I think I finally have it. All right. So anyway, let's back to this lesson. What else? Second way to solve a quadratic equation is by something called extracting roots. The third way to solve a quadratic equation is by the square. You may use that term already. And there's a fourth way to solve quadratic equations using, and I know you've all done this in the past, using the quadratic formula. And then number 5 is doing word problems that can be applied that way. All right, so let's get a start here. So, first of all, top of the page here, 2x squared plus x plus 7 equals 3. Can you solve for x? Well, one way to attack this is to get it equal to 0, because then factoring makes sense. Let me explain. It doesn't help at all unless there's a 0 on the right side. Do you get why? Why do I need this here? Because the two factors multiplied together, let's say to equal 10, there could be a trillion different things that multiply out to equal 10, not just 1 and 10, 2 and 5, 2.5 and 4, there's a million of them. But when the answer, somebody trying to talk to me? What? Can almost hear, well, must have been a mistake. All right. When the answer is 0, I guess that was me, that was feedback. When the answer is 0, something special happens. The only way to get 0 is an answer multiplication per one of the two factors is 0, or both. So this is called the zero product property. So let's get that 3 out of there. I subtracted 3 from both sides, and now I have plus 9x plus 4 equals 0. Now let's attempt to factor. And as we learned previously, oh yeah, this one factors, maybe not the easiest factor job, but it factors. And once you've got that, well, the culprit, the first factor could equal 0, so could the second. You wind up with 2 separate little linear equations that are very simple to solve. And you get, both of those are candidates. X could be equal to a -1/2. X could be equal to -4. So, right off the bat, a quadratic, because we have a second degree, now we can have up to equations. Whereas when you did a linear equation, we could only have as many as 1. The maximum number of solutions always equals the degree. So if we later do a 5th degree equation, there could be as many as 5 solutions. 7th degree could have up to 27 solutions. So anyway, don't worry, we're not going there. But second degree, and you might have 2, you might have 1, you might have none, but 2 is now a possibility. Here you can see we got 2 answers. You can go in and check them, and you'll see they both work. All right, so that's of using factoring to solve a quadratic. Let me just repeat. The first thing you got to do is you got to get it equal to 0. Otherwise, it's hopeless. After you get it equal to 0, can you factor it? And if you can, wonderful. Set each factor equal to 0 and solve. Okay. Now, here's a different kind of a problem. You may not notice it, but look at this quadratic. X squared minus 6x plus 9 equals 7. Couldn't I just start off by subtracting? You could. But you'll see it's not very factorable. Here it is, right down here. Look. Is that factorable? Whoops, wrong tool. Is that factorable right there? No. There are no 2 factors that multiply out the 2. So anyway, look up here on the top. So here's method number 2. How many of you noticed that x squared minus 6x plus 9 is a ding-ding-dinger? May not have spotted that, but oh, that's a perfect square trinomial. The first term is a square, and the last term is a square. And if you take the 2 square roots, which are x and 3, and multiply them and then double it, the term has a 6x. So that means I could write it like this. You're probably thinking, well, big deal. Actually, it is a big deal because now, because of square, you can take the step of taking both square roots. This line. What's the square root of x minus 3 squared? X minus 3. And what are the 2 square roots of 7? Plus or minus the square root of 7. Almost there. We wanted to solve for x. All I got to do is get this minus 3 out of there. Add 3 to both sides. Bingo. 2 solutions. 3 plus the square root of 7 plus the square root of 7. I'm going to pause for a minute. I may have, hopefully I didn't blow by you. So far we've gone through 2 ways to solve a quadratic. Way 1, get it equal to 0 and try to factor it. Set the 2 factors equal to 0, solve. If you have a perfect square trinomial on one side of the equation, you could write it as a perfect square and then proceed by taking square roots. I didn't realize it, but on the bottom of this page is a third way. Do you recognize it? Do you recognize it from your previous math? What did I do? That's the quadratic equation. Do you remember that? X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Anyway, that's what that is. And the point is, when I go way to the bottom, right now, don't worry about it. I didn't mean to go through it that fast. But here's the point. At the bottom, if I divide top and bottom, 2 out of the top, and simplify, guess what I get for an answer? Answers I got right up here. So I'm not joking when I say these are multiple ways to solve a problem. They really do come out to the same solution. So why are we teaching you all these ways? And I haven't even gone through completing the square yet. Why are we doing this? Because in different situations you need, sometimes you need a different way. There's just no other way. There are a couple times when you can use your preference. But you really, I need you to be armed with these different techniques. So I'll just pause for a second. Anybody want to ask a question about these two techniques? I mean, we're going to be doing a ton more examples, so I don't mean I'm done, but follow-up question or anything? Okay, let's just move forward then. So here's another example of the one we just did, completing this, finding a ding-ding-dinger. No, this is completing the square. You know what? I'm going to do this one over. This stuff gets in the way. Oh, I don't have my delete key. Okay, well, I got almost all of it. All right, so here we go. Oh, you can't factor this, by the way. So let's not even, we're not going to go there. You can't do it. Could we use the quadratic? Sure. We're just hanging out. We're going to get there. But can you do it? Here's the technique called completing the square. When you complete the square, is you get rid of the constant. That is, get it to the other side. Add 1 to both sides. So now, what I'd like to do is fill in this blank with the number that makes the left side a ding-ding-dinger, a perfect square trinomial. So here's how you can do that. You take the b term, that is the number, which is the coefficient of x, and we don't care about the sign, so it's 1 right now. Okay? Divide, take half of it. What's half of 1? 1/2. And now one more step. Take that and square it. Squared, 1/4. That's the perfect thing to add to make that left side a ding-ding-dinger. Of course, I can't willy-nilly add 1/4 to one side of an equation unless I also add it to the right. Now I've made it legal. So let me just repeat. You kind of vacate the constant first. You're going to calculate what's the perfect number to add there that will make that a perfect square trinomial. How to find it? Look for the x term. What's its coefficient? Take half of it and square that. That's the perfect number to add to both sides of the equation. So in this case, 1/2 of 1 is 1/2. 1/2 squared is 1/4. Bingo. Add that to both sides. Now, because I did that, should be a perfect square. Can you tell me what goes in there? it's easy. Just take the square root of x squared and put that there. Take the square root of 1/4, put that there, and take the sine, you know, the sine right here from the, and put that right there. By the way, I did that wrong. You take the sine on the b term there, so it's a minus. So now, if you multiply it out on the side, x minus 1/2 times x minus 1/2, guess what? You're going to get x squared minus x plus 1/4. Okay? On the right, 1/4, 1 plus 1/4 is 4/4 plus 1/4 or 5/4. Okay, so you're probably thinking, why did we do that? Well, now we could, because we have a perfect square, we can take square roots. So take the square root of the left side and take both square roots of the side. By the way, square root of 5/4 is the same as square root of 5 over the square root of 4. So I could write this right side like this, because we know what the square root of 4 is. So now we sit right here. The goal was to what? Find x. So now all I have to do to solve for x is add 1/2 to both sides. So I just add 1/2 to both sides, and I get this. And by the way, you notice those both have a denominator of 2. So usually the final way to write this is put it over a common denominator in this form. So what that's telling you is one answer is 1 plus the square root of 5. And the other answer is 1 minus the square root of 5 divided by 2. No surprise that there's two answers, because this is a second degree equation. It can have as many as 2. So this is the technique called the square. In this, and in this problem, what's the square? That thing with the exponent 2 on it. That's what we completed. This empty polynomial up here became a square. This is actually a very important technique. Without this, the quadratic would never have been discovered. And that's where eventually we're headed. So now I've shown you 3 techniques. Technique 1, solve by, get it equal to 0 and factor it. Okay, and then just set the 2 factors equal to 0 and solve. Technique 2 was, I lost it. What was technique 2? I got to think. I got to peek back. Technique 2 was, oh yeah, just if it's already a perfect square, take square roots. And then technique 3, the one I just went through, is this third one here, completing the square. Okay, so that brings us to number 4, the quadratic formula, which it looks like we have just enough time to start on at least. So please talk. I'm trying to think of the best way to talk about it because I only have 5 minutes. So what I'm going to do is just talk about the quadratic formula in general here. Here's how the quadratic formula is stated. If you have this equation to begin with, if you have an equation in that form, and by the way, A, B, and C can be filled in with any integers, then what's the answer? I know you've had that in a previous math class. Now, what we're going to do tomorrow is we're going to show you where that formula comes from. And guess what? We're going to use completing the square. But right now, I want to just practice. Okay? So let's take, I'm going to make up an equation. 3x squared minus 2x plus 9 equals 0. Let's use the quadratic to find out. So let's so what's A, B, and C? A is the coefficient of the squared term, B is the coefficient of the first degree term, x, and C is just the constant. X equals, what's B? -2 in this problem. So what's minus B? +2 plus or minus square root B squared. What's -2 squared? 4 minus 4 times A, which is 3, times C, which is 9, all over 2 times A. 2 times 3 is 6. You guys all know how to do this. 2 plus or minus. Now we got some arithmetic to do. Yeah, this one's not going to come out to be very sensical, is it? What's 4 times 3 times 9? 12 times 9? 108. What's 4 minus 108? -104. So this is impossible. This particular one has no solutions. Why? Because we have a negative under the root and we're stopped in our tracks. By the way, does that make sense? Can a quadratic have no solutions? Yes. Remember, a second degree equation can have up to 2 solutions, but it may have less. This one has no real. Actually, there are some so-called imaginary solutions, but we're not going to imaginaries at this time. So now, let me just recap here. We actually have gone through 4 to solve a quadratic. I'm just going to go back and refer to my list again. The first one was, if it's equal to 0, start trying to factor. The second one is, if it's a perfect square, cool. You can just start by taking square roots of both sides. The third one is, if it's not a perfect square, you can make it one, called completing the square. And then you can proceed with the same technique. The fourth one, the one we just talked about, is you could use the quadratic formula to solve. So we're getting down to the last, we don't really have any more time. I'll just return to that last slide where we were. Questions on what we went through for new material so far? Just to repeat, no, you can look what the assignment's going to be. I don't remember it, but it's posted, I believe. And what we're going to do tomorrow is I want to do a ton more examples, and I want to develop the quadratic formula together with you. And then we'll start doing some problems from the assignment. Well, I think you guys set a new record for questions. Didn't get to number 45. I will do that directly to that person who sent me the text message. So all together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions. Way to go. Good questions. Thank you. Any final questions or items before we call it quits here? Okay, thanks a lot, guys. Video should be up in just a few moments. Thank you.